Hi friends! Today we continue study electronic components and the topic of this conversation is electromagnetic relay. The relay is a simple component with contacts. Contacts can stay in a closed or open position depending on many factors such as temperature, current in the circuit, voltage, and so on. Today we will talk about the electromagnetic relay. Electromagnetic relay is an electromechanical device for switching external circuit. It consists of solenoid and contact plates. The first prototypes of electromagnetic relays have been created a long time ago, before the advent of the electronic devices. To understand the principle of operation of the relay, we go back to the textbooks on physics and collect simple device. We wound certain amount of copper wire on any iron object. If we apply voltage to this coil, the iron core or the anchor will attract the ferromagnetic materials, in other words, substances which can interact with magnets. In fact, we have complied a simple electromagnet. It would be unfair not to mention the legendary names of Andrew Mary Ampere and Michael Faraday. Their empirically proven relationship between electricity and magnetism. This discovery became the basis of our world. The relay is a sum of electromagnet and movable and fixed plates with the contacts. At the time of actuation of the electromagnet, these groups are put in contact. Depending on the type of relay, it can have from 1 to 10 or more plates with contacts for switching multiple loads. The main function of the relay in a circuit is to turn on and off loads or consumers by applying a weak signal at the solenoid coil. In fact, it is a trivial switch which is controlled by a weak current. Moreover, the electromagnetic relay as a conventional switch can work in AC and DC circuits. We have a button that can tolerate currents about 2 amperes, but we need to connect to a power source, for example to battery, powerful lamp, which consumes much more than 2 amperes. We cannot use this button because contacts will burn up, but if the bulb connected to the relay contacts, which can withstand much higher current, control of the lamp isn't difficult. In this case, the button provides a small current to the coil of the solenoid, causing the relay contacts become closed. The relay can be of two types. First are usually the same solenoid, and the second is solid-state relay. In the latter, there is no solenoid. A relay has a fully electronic stuffing, and we haven't mechanical switching contacts. It includes power semiconductor devices such as thyristors and transistors. Perhaps some people will be surprised, but the simple relay caused the rapid development of technology. Without the relay, we would not have today's computers and other digital devices. The relay can be in two states. The contact is open or closed. This is nothing more than a binary code, either 0 or 1, on the basis of which all digital devices operate. The first prototypes of computers were built using switches and punched cards. Punch cards are a way to program management mechanisms which was proposed by French inventor Joseph-Marie Jacquard about 200 years ago to manage looms. The first computers were bulky, noisy, but it was thanks to them that there was born PCs. A prime example in the world's first programmable computer built in 1941, designed by Conrad Zuse and included more than 2,500 relay. Such a computer could perform complex mathematical calculations by using binary code. Although the name of the inventor has been forgotten and the world hasn't appreciated his invention, nonetheless, Computer Zuse is the ancestor of modern computers. Same way worked computer designed by genius mathematician Alan Turing. His computer was able to decipher the German code, the legendary Enigma cipher machine of the Nazis, which was considered impossible to crack. This contributed to the victory in the Second World War, but the Germans weren't even aware that their extremely complicated cipher machine was hacked. I slightly go away from the subject, but additional information is never superfluous. In diagram, the relay looks as follows. The square is a solenoid and a number of contacts. The main parameters are the relay coil supply voltage, maximum voltage, and current across the contacts. These parameters are marked by the manufacturer on the body. Here we can clearly see that the solenoid is designed for a DC voltage of 12 volts, and the maximum current in the case of switching the network load can be up to 10 amperes. Conventional relay has several disadvantages compared with solid state. Power contacts eventually will burn up. The second drawback is the noise at the time of the solenoid working. Relays are widely used in all industries, in transport, household equipment, power generation, and so on. We meet them every day, but do not notice it. In the usual UPS or voltage regulator can be seen several relays that instantly react to main voltage fluctuations. Depending on the application, the relay may have a different size, shape, and allowable current. There are switches on hundreds of amperes which are implemented in the power automation systems. As another example, let's examine the simple thermal relay. In this scheme, we see a thermistor that changes its resistance depending on the ambient temperature. With increasing or decreasing temperature, transistor will acting and supplies power to the solenoid coil, so relay can activate a cooling system or, on the contrary, heating. Using a photoresistor instead of a thermistor, we will get an automatic switch that can turn the lights on in darkness. Some people complain that my videos have become ends abruptly, but the video time is limited due to many factors, so it is time to complete this instructional video. I hope it was useful, and if so, don't forget to estimate it with like and share it with your friends. Well, I bid you farewell. With you was Kasyan TV.